graphs compare the results of several trials or relative amounts. It is not used to show the relationship between two numerical values like a line graph is. Take a look at this chart, this data table. We're looking at the amount of rainfall that has fallen over the course of a year. You can see that our independent variable, the month, is qualitative data. It's just a word, January, February, March, April, and so on. Our dependent variable is the amount of rainfall that fell in each month. This is quantitative data. We see numbers here, 2, 11, 5, 10, and so forth. This is why we're using a bar graph, because we don't have two numbers. If we had two numbers, then we'd be using a line graph. A bar graph is set up a little bit differently from a line graph. There are some similarities. For example, our x-axis is still along the bottom side of the graph, and this is still where we're going to place our independent variable. The y-axis still goes along the left side of the graph, and that's where we'll find our dependent variable. In this case, our independent variable is the time in months. So we'll place that along the x-axis. Our dependent variable is what we're discovering throughout the course of our experiment. In this case, we're measuring the amount of rainfall that has come down during each month. So we'll place that on our y-axis. When creating the intervals for our bar graph, we need to make sure that we can fit our data onto the graph. Our independent variable is the time in months. This is qualitative data, so we pretty much just need to make sure that we can fit all of the months of the year across the bottom. The dependent variable in this case is quantitative data, so this gets a little bit more tricky. We need to make sure that we can fit the numerical data on that y-axis. We can see that we have 1, 2, 3, 4, 5, 6, 7 lines going across on our y-axis. And if we look at our data table, the largest value we have for rainfall is 31 centimeters that fell in July. That's our greatest value that we need to fit on our y-axis. So we need to make sure that we space our y-intervals accordingly in order to fit that data point on there. Since we have 7 lines, we could make each of those lines represent 5 centimeters of rainfall. So we start with 0 down at the bottom and increase by 5, 10, 15, 20, 25, 30, and 35 all the way at the top. So we have 35 centimeters of rainfall space available to us. And again, the largest data point is 31, so we can be sure that that will fit on there. Now that we've properly set up our bar graph, we just need to add the data. So looking at January, we see that 2 centimeters of rainfall came down during January. So we need to draw a bar above January in our x-axis, and it needs to extend to 2 centimeters. There we go. So now we can see on our graph that in January, 2 centimeters of rain fell. When we move to February, we see that 11 centimeters of rain fell. So we draw a bar that extends up to the 11 centimeter mark on the y-axis. In March, we had 5 centimeters fall. That one's easy. We can make it just go straight to the 5 centimeter line. In April, 10 centimeters of rain fell. Again, an easy data point to put up. Our bar extends to this 10 centimeter line on the y-axis. For May, we had 11 centimeters, so our bar needs to go just above that 10 centimeter line, kind of like in February. In June, we see 23 centimeters of rainfall. That's quite a bit. So we go to June on the x-axis, and we'll count those lines upwards, 5, 10, 15, 20, and then we just need to go a little bit higher than 20 to make it look like 23 centimeters. In July, we have our largest data point, 31 centimeters. So we're drawing a bar that extends upwards just above that 30 centimeter line. For August, we have 22 centimeters. The bar will extend just above that 20 centimeter line. For September, we need to draw a bar that has 16 centimeters. There we go, just above that 15 centimeter line. For October, we're down to 5 centimeters of rain. Short little bar going up to the 5 centimeter line. For November, we have 9 centimeters, and December, 7 centimeters. Now you can see this visual representation of the rainfall that's occurred over the year. It's a very quick reference. You can kind of see much more easily looking at the graph that the most rainfall fell in July than looking at the data table. It's a lot more difficult to kind of have to actually read those numbers. So a picture's worth 1,000 words. This bar graph shows our data very nicely.